Yeah, hello. I was invited to present, to do the last presentation of ROSIN FTP. First, a few words about our company. Name is Trygve Thomessen. I'm managing director of PPM Robotics in Trondheim, Norway. Also working at part-time professor in Budapest University and Chuo University in Tokyo. Our company is basically working with industrial applications, high-tech application, and as I will show you, we take a big advantage of ROS as a part of our business model. We have also stolen a bit of the ROS logo, however, changed it a little. So you see this is a welding project, so I hope it's okay. And our ROSIN FTP is a ROS-based framework for planning, monitoring, and control of multipass robot welding. Yeah. PPM, we are then located in Trondheim in Norway. It's the third biggest city, or actually a town, with around 180,000 people. University technology is there with around 40,000 students, so it's quite big. And our former mayor said that we probably were one of the cities in the world with the highest IQ per square meter. I don't know how they measure it, but So Trondheim is about 500 kilometers north from Oslo, and as you can see on the picture on the top there, we are now in the middle of the dark season, where we have 3-4 hours with daylight, and then it's completely dark. On the other hand, during the summer, we have 24 hours, almost 24 hours sunshine. To the right, you see some examples of different ROS projects. I didn't have space to, let's say, to make a big presentation of it. But as you see, we are really utilizing ROS as a core part of our business. And the reason is very simple. I mean, we started as probably most high-tech companies, making everything from the bottom, developing things, and find out that basically the schedule we made for the project we can multiply with 3.14, and then we have the realistic estimate for the technology development. What we see now, thanks to ROS, is that we actually we make our unique part on top of the ROS framework, and we can do it much faster. The customer get results much faster, and of course, as a business model, is working much better. Had similar presentation this morning, and I showed an example then where we made a full 3-division system for a company in Korea, and we offered it for a lower price than the full industrial version. And then the customer had then the software for use afterwards, and so he had, I mean, a first-time investment, but then could reuse everything afterwards, only by adding the hardware for the camera, which was around 8-9K euros. Some of the applications to the upper left, it's a heavy welding project. To upper right, we have a deburring project. Then we have a big grinding project, and also some CNC. Common for this project is that there are small series production as a one-of-a-kind production, and this is a part of the challenge we are facing also here in this ROS FTP. This means that you have to be able to plan, verify everything on the computer before you actually start a robot running. For the simple reason that you have only one item or one product to manufacture, so you can't do multiple testing of it. So for this Roswell FTP, we picked out one of our most advanced applications. That's a heavy multipass welding. So it means typically applications where you have 5 and actually up to 100 passes to be able to fill up the groove. And in these applications, you need both to have the planning phase with model of the welding process. You need to check all the trajectories for a collision, and you need also to move through the whole welding. However, I mean, always in heavy welding projects, there's 20–30% magic on top that you are not able to model. And to deal with this, we also have introduced a welding camera, so the operator can monitor the welding all the time and do some minor adjustments. So let's say typically the robot can then weld 5 to 10 passes, and then the operator on the next need to do some small adjustments. In the ROSweld project, we will develop then a ROS-based framework for the planning, monitoring, and control of these applications. In addition, we'll put on top user-friendly graphical interface. We'll then use the Flex GUI system that we introduced to ROS from before. And of course, it will be assembled then from components we develop together with the existing ROS technology. There are 3 partners in the project. PPM, we are the coordinator and main responsible for the software. However, we have 2 partners with us. One is Rainpower. They are manufacturing huge hydropower turbines. Normally, welding time from 2,000 to 20,000 hours is quite big, actually. They are located close to Oslo. In addition, we are also collaborating with a new lab in the southern part of Norway called Mechatronics Innovation Lab. It's one of the catapult centers for automation and robotics that the government has established. There are actually 2 of these now with a lot of equipment. So this demo will then both be done in the industry and in the Mechatronics Innovation Center, so people also have the chance to easily see it afterwards. Yeah. Of course, we will release everything as open source, except our core IP, which is the modeling of the welding process itself. So this is the secret, but we will make the framework so anyone can put in their models there. What is also important, of course, we will release it at open source and also do the necessary documentation of it. What is also important here is that this will be a kind of general frame for I would say, advanced robot applications like grinding, gluing, welding, soldering, etc. So the framework we try to do is make it as generic as possible. And also, so it becomes a kind of best practice industrial example for to use ROS. So far, we are in the first phase, what we call the connectivity. So we are developing basically the drivers for the ROSweld. Currently, we have Nachi, OTC, and Hyundai, and of course Move It driver. And we will, of course, also interface the standard drivers that are already present in ROS, like I think Yaskawa, of course, UR, etc. What is important with these drivers here that they are extended drivers. That means that you can access all the variables inside the controller also. It's not only on the real-time part. And the reason we have made these also extended drivers is that when you go to industrial applications, you actually need to, let's say, take advantage of industrial tested things. However, we also have, of course, the Move It there, so more for laboratory applications, where it's not so strict with CE marking, etc. Then you can, of course, utilize that. Also interface to welding power sources from Fraunhofer OTC, arc sensor, touch sensor, and also laser scanner and welding camera. So as you see here, we based everything on ROS, communicate through the ROS bridge to the graphical user interface, where we will have a special ROS-Weld UI, which is then designed for process control, and Flex GUI, which is more for, let's say, for the commands. In addition, we have a interface to the welding power sources through VPS driver, and also to laser scanner, which we currently are using the MEL from Munich, and of course the Nachi OTC driver as well. We have the plan with the project is to finish the milestone 1. It was actually to finish it now before Christmas, but we are a little delayed, so we plan now during February to finish it. And basically that's about the connectivity, where we currently have set up a test in our lab now, both with the 7-axis Nachi robot. We have welding power source, laser scanner, IP camera, and we're also applying welding camera there. So yeah. We have, this is just an early concept here. Maybe it's a bit laggy, but maybe you see a little. Okay, I just skip it. Okay, you can upload the presentation afterwards. Yeah, it's very laggy. Okay. The phase 1 connectivity is again going to be finished now in February, and then we go to the planning, modeling part, and then during May, June we will have then the industrial verifications of the project, and also upload everything to the ROS database. Thank you.
So, thank you, Trygve, for your presentation.